Dear students and learners, again welcome from Dr.SUJA. This is my second video regarding the first unit of thermodynamics. Okay. Uh, in the first video, we have studied about the various fundamentals of thermodynamics and the types of systems was explained. And now here also we are continuing the same first unit. And now uh, uh, closed, open and isolated systems are a very important point of view in thermodynamics. Like homogeneous and heterogeneous systems are also a key point which gives you the how the system is reacting for the transfer of heat and work. Okay. Homogeneity and heterogeneity is nothing but the how the components or the composition inside the system is distributed, and they are having the impact on or effect on the energy transfer. Okay, so we have to learn the system which is homogeneous or heterogeneous. Okay, so the system which is existing in single phase is called homogeneous, and heterogeneous means they will be existing more than one phase. Phase means here the state of a particular phase. Okay, and also the composition, whether the composition is distributed in the uniform way or not. Okay, so here you can see if it is a pure substance means you have this single element, and if it is consisting with another one more one more type of component means then it would be a compound substance. And in terms of mixtures means this is homogeneous means the distribution is uniform in all the places, and if in the heterogeneous means here you can see the types of components are not distributed evenly. Okay. Uh, now we will come to we will study about thermodynamic properties. Okay. Mass is nothing but a quantity of matter or the substance which we are taking in which is measured in kilograms. Weight, mass is different from weight, you all know. Mass is kilogram, and the amount of mass which is uh, attracted by the earth is only weight. So the force exerted on a body by the gravity. Okay. So this is weight is measured in Newton. And volume is the space occupied by the matter or the substance, how much amount of place is occupied. Okay, a specific volume is volume per mass, unit mass. Okay, so meter cube per kg, this is meter cube, and the specific volume is meter cube per kg. Specific weight is, weight means Newton per meter cube. Okay, again density is mass per volume. Temperature is a degree of hotness or coldness measured in terms of degrees Celsius or Kelvin, and Fahrenheit or Rankine. Pressure is the force applied or exerted per unit area. Force is measured in Newton per meter squared. Specific heat means the amount of heat energy required to rise or lower the temperature of the substance about 1 Kelvin or 1 degree Celsius. Specific heat. Okay, so Newton. Energy, internal energy is one type of energy possessed by the molecules within the system. Work is also another type of energy. Here the movement takes place due to molecular movement, and heat is a type of energy. Flows takes place due to temperature difference, existence of temperature difference. Enthalpy is the total heat content of the system consisting of the summation of internal energy and the flow energy. The heat gives the increase the internal energy, and as well as because of the increase in internal energy the flow will takes place. The total addition of internal energy and flow energy gives you the enthalpy. Okay. Then now we will move to types of properties. Intensive property, extensive property. Two types of property we are going to study now. Intensive property. By the name itself we can understand intensive. Intensive means intensive properties are independent of mass of the system. Whatever the mass of the system, these properties will not change. Okay. Like temperature, if you are measuring the temperature for the whole system or a part of the system, either for 1 kg or 2 kg or 3 kg of the same substance, the temperature would be same. Pressure, density, specific volume. Okay, how much mass you are taking, that is not a matter. Instead, for any mass, the intensive properties would be same. Extensive means dependent on the mass of the system. If you are finding the internal energy of the system or any type of energy for 1 kg of mass, the energy would be different from 2 kg of mass, right? Okay, the volume or the space occupied by 1 kg of substance and 2 kg of substance is also different. Yes, enthalpy is also heat content, total heat content also would be different for different mass. Okay, so intensive means independent, extensive means dependent on mass. Next, here you can see the SI units for various properties of the thermodynamic characteristics. Okay, pressure and its units. Why we are studying about pressure, temperature, volume is whenever you are giving the temperature to any system, its pressure would be increased or change in pressure will occur, and that should be measured, and as well as impact of the pressure also should be studied. So here thermodynamics means pressure, temperature, volume is the key properties. Okay, so measurement of pressure is very significant, and already it was defined, and SI unit 1 Pascal is equal to 1 Newton per meter square, and other all units bar 1 bar equal to 10 power 5 Pascal. Okay, atmospheric pressure is 1.01325 Pascal. Okay, now other units also has been given, because in the problem if they are giving the pressure values in some other units means you have to convert and then into SI units, and then you have to proceed the problems. Okay, and types of pressures. So in the first units itself we are studying about pressure and its measurement and its various units, etc. Okay, so absolute, gauge and vacuum pressure are the various pressure types which is expressed depending upon the system pressure. You can able to differentiate these pressures, like here this is the zero absolute pressure, which is here you can you have the absolute pressure, which is the summation of the pressure measured by the gauge and the atmospheric pressure. The summation of atmospheric pressure and the gauge pressure will give you the absolute pressure, and gauge pressure is the pressure which is measured by the gauge, and vacuum pressure is always below the atmospheric pressure, and you can also find out the absolute pressure in the negative side by differentiating the atmospheric pressure and the vacuum pressure. Okay, temperature is the degree of hotness or coldness measured in degrees Celsius and Kelvin, or Fahrenheit and Rangin. Usually we will be using this SI unit of degree Celsius and Kelvin for all the problems in this course. And here you know very well that freezing point of water, what is a freezing point of water, is 0 degree Celsius. Okay. What is boiling point of water is 100 degree Celsius. So the Celsius scale would be from 0 degree Celsius to 100 degree Celsius. It is for freezing point and boiling point of water. In the Fahrenheit scale it is 32 to 32 and boiling point is 212 degree Fahrenheit. And if you are converting to Kelvin scale, so freezing point of water is 273 Kelvin and boiling point of water is 373 Kelvin. Specific heat capacity. Here heat capacity, heat, the amount of quantity or amount of heat required to rise the temperature of the unit mass of material or the substance through 1 degree Celsius. How much capacity of the substance which would take the quantity of heat and rise the temperature of the matter to 1 degree Celsius is only specific heat capacity. Okay. So this is expressed in terms of kilojoules or joules per kg Kelvin. Mass, specific means per unit mass, to increase 1 Kelvin. Okay, how much amount of heat is needed? Okay. So this specific heat is expressed by two ways: specific heat at constant pressure Cp and specific heat at constant volume Cv. Here for air the values have been given, and another one more thing is you can relate this both Cp and Cv by the term universal gas constant. Is nothing but the difference between Cp and Cv. State, processes and cycles. State by the term state. What is the state? What is the state of us at that particular time? Okay. Why it is needed? Why this state is, this term is should be described in thermodynamics is, we cannot name the systems. 1 kg of ice we cannot name it, and we cannot differentiate the systems by giving or keeping some names. Okay, so instead how we are specifying or expressing the systems is only by various properties or characteristics which completely describe the system state. Okay, so state is the condition of the system at that particular time. What is the condition of the system is described or is expressed by the values of the properties. Okay, properties such as temperature, pressure, density, composition, etc. Okay, at a particular time, what is the state of that system? Second, process. This is first state, this is second state. Here the pressure is P1 equal to 100 kilopascal. Here the pressure would be 200 kilopascal. Okay. How the pressure is increased? Pressure has increased. Okay, by some of the process. Either it may be heating or pressurizing at any one type of a process. Okay. So change of state. Change of state. A system undergoes from one equilibrium state to another is defined as process. So here you can see 1 to 2, one process, 2 to 3, another process. Okay. State, how many states here? 1, 2, 3, 3 states and 2 processes. Processes need 2 states, initial and final state, initial and final state for 2 to 3. Okay. Thank you. Thank you for listening.
Thank you.